All right, the other day we dealt with equations with absolute values, so now let's go into our squares and squaring and essentially what gives us graphs of parabolas. So what we're going to be dealing with is this guy, this y equals x squared. This is kind of the base thing that we're looking at. So first of all, let's just go ahead and graph it, kind of see what it looks like in general here. I'm going to grab my calculator, go to my equation editor, y equals, and we're going to type in x squared. And let's graph that. I'm on Zoom Standard right now. Ooh, so now it kind of like comes down and it rounds off and then it goes back up. Okay, so we call this guy a parabola. So this general shape right here, when it's rounded and it's basically symmetrical, we call this a parabola. Okay, so the parabola is for the graphs when our x is squared. Okay, there could be other things with it, but if it has an x squared and no higher degree, we're going to have a graph of a parabola, and it looks just like this. It could be going downwards, and we'll get it into more of that next chapter. So if I think about it on a table, why that is because when we take the x and we square it, what happens is, for example, with negative 3 and 3, if I take negative 3 squared, I always should put it in parentheses, I would get 9. Well, if I do the same thing with 3 squared, I also get 9. Okay, so that's where it's kind of symmetrical. And if you notice, this is what we call the vertex, and we'll get more into that, is the point at where it's symmetrical at. So, if, for example, this is 0, 0. If I went over 1, I would go up 1. Over 1, up 1. If I went over 2, I would go up 4, because 2 squared and negative 2 squared is both 4. And then 3, 9, and negative 3, 9. So it's symmetrical. So when I graph this guy, there's like a mirror going through it right here, which we call the axis of symmetry. And we'll get into that later too. That makes it symmetrical. So this guy's a parabola. Graph of the x squared. And would this be a function? Well, could I draw a vertical line where it would ever cross it twice through one vertical line? Nope, these all cross at once. So yes, it's a function, right? Each input has only one output. Like I couldn't plug a 12 in for x and get two different answers for y. I only get one answer. What's its domain? Well, let's see. This baby's going to keep going on forever this way. It's going to keep going on forever this way. So are there any x values I cannot plug in? Can you think of an x value I couldn't plug into that equation? No, if I plugged in an x value, I'd get an output. So the domain is really all real numbers. Every single number works for its x's. Would that be the same for the range? No, not necessarily. Look at where it bottoms out. Right here, it doesn't get any lower when y is 0, right? But it goes on forever vertically. So it doesn't go any lower than 0, but it goes above that. And is there an ending point? Would I like say it's between, 10? No, it goes past that, so that doesn't work. So we just say y is greater than or equal to 0. I could flip that around and say that. It looks a little nicer that way. So that would be its range. It's exactly 0, right? So that's why I include the equal to. Okay, but it's all that are greater than 0. Okay, so let's think about the solution for this guy. X squared equals 36. Well, if I do this algebraically, what we do is, remember we always do the inverse of what's being done. And we're trying to get the x by itself, so I got to think, what's the inverse of squaring? So if I think of inverses, the inverse of adding is subtracting, the inverse of multiplying is dividing. If I think about the inverse of squaring, that would be square rooting, right? Because if I took, the number 4 and I squared it, I'd get 16. So if I wanted to go back to 4, I would have to square root 16 to get back to 4, right? So those guys are inverses. So if I'm going to solve this problem, I would square root both sides. And that actually cancels that square, so I'm just left with x. And if I take the square root of 36 on my calculator, I get 6. But is that the answer? Is it just 6? Well, let's think back to our table here. Let's look when y is 4. I'm going to plug 4 for y right here. 4 equals x squared. Well, if I try to solve for x, I'd square root both sides, and I'd get 2. But isn't it 2 and negative 2? There's two answers, right? Because when y is 4, I get 2 and negative 2. Okay, so we have to consider that case when we take the square root of both sides. So our rule is going to be, whenever you take the square root of both sides, you need to put a plus minus in front of it. Because what that really means is the x really equals a positive 6, and it equals a negative 6. Right? And remember how I can do this on my graph? How I can solve for this on my graph? I can graph this guy as an equation, y equals x squared. And I can graph this guy as an equation, y equals 36, and I can find their point of intersection, or points of intersection. So for example, y equals x squared, and y equals 36. And I might say zoom fit just to make sure they fit, which is 0. So there's my x squared, there's my 36. And if I wanted to find their 2 points of intersection, I'd go 5 for intersect, first curve, second curve, take a guess. Now I might actually want to go guess at one of these because there's 2 of them. I'm going to guess that one first, this left one on the left. There we go. So negative 6 is an answer, which I'm guessing this one must be 6 as well. I'll just quickly do that. Just when you make your guess, make sure you take your guess more towards that point. Otherwise, it'll pick the other point of intersection. There we go. So 6 as well. So x would be 6 and negative 6. So if I did one more of these guys, if I said, let's just say, h squared equals 25. Okay, so whenever I square root both sides, to get the one part by itself, I always say it's plus or minus on the other side. So it's plus or minus the square root of 25, and the square root of 25 is 5. And I could leave my answer just like that. That's fine. Or I could write it as 5 and negative 5. Either way would be just fine. Okay, when things start to look a little different is when you get this. Okay, so if I look at this left guy, it says x minus 3 squared equals 100. Well, I can't add the 3 right now because it's in these parentheses with the square. So I have to get rid of this square first of all. Well, and we just talked, how do I get rid of a square? You do the inverse of what's being done. So we square root, right? Because that's the inverse of squaring. And whatever I do to one side, I do to the other. So this square root will cancel with the square, and I'll just be left with x minus 3. And that'll equal, well, remember, anytime you square root both sides, I need to put plus or minus. So it's really plus or minus the square root of 100, which is what? Yeah, 10 times 10 is 100, so this plus or minus 10. So is that going to be my answer? No, what do I have to do still? I have to add 3 to both sides. But be careful here, because what does this mean? This really means positive 10 plus 3. And it also means negative 10 plus 3. So I should get x equal to 13 and negative 7. So be careful with that. Because what I see a lot of times happen is this. People will get this answer. They'll go x minus 3, and they'll say plus or minus 10. And they'll add the 3 over, add the 3. And they'll think, yeah, 10 plus 3 is 13, so 13 and negative 13. No, that's not correct. Right? Because it's 10 plus 3, and it's also negative 10 plus 3, which is negative 7. So be careful with that. Okay, I see that quite often. Well, how about up here? Can I square root both of these guys right away? I could square root these, but then I have to take the square root of 4, and this gets confusing. We haven't learned all those properties with square roots. So my best advice is whenever you have something being squared, get it by itself before you square root. Well, how would I do that? Well, I have to get rid of this times 4 right here. So how do I get rid of a times 4? It's inverse. You divide by 4. And whatever I do to one side, I do to the other. So the 4 divided by 4 cancels, and I'm left with x plus 4 squared still equals 9. And now the inverse of squaring is square rooting. Whatever I do to one side, I do to the other, so those cancel. So x plus 4 would equal, remember, plus or minus. Don't forget the plus or minus, 3. And then we subtract 4. So x would equal, remember, 3 minus 4, which is negative 1. Right, so I got 3 minus 4, and I also have negative 3 minus 4, which is negative 7. There we go. So lots of times we get two answers for this. Lastly, the same thing is the case. Whenever you have a square, make sure that you get everything away from it. So I'd subtract that 4 first, which I'd get x squared equals 25. And then we should know that negative 5 and 5, right? And when I square up both sides, I put my plus or minus for 5. Remember, so that's really 5 and negative 5. What about this guy? Same thing. Get that squared by itself, that x squared by itself. So subtract the 16 over first. So I'd have 2x squared equals negative 6. Divide by 2. And x squared would equal negative 3. And to get rid of this square, we square up both sides. And x equals, well, what happens when you try to take the square root of negative 3? It does not work, right? So this is not possible. So there's actually no solution in this case.